Hey everyone, so I'm just gonna brief update about yesterday. Sorry, not tomorrow, yesterday. So, yesterday when I came back from some stuff I had to do in the hospital, I had to run some errands um, for my mom. I had to get her chemotherapy done, but that actually got skipped because she wasn't feeling particularly well. I came home and I was just like exhausted. I don't know what happened, it just came out of nowhere. Um, I technically kept the ball rolling by putting out that YouTube short yesterday, but also I felt that like drop recently just because things have been like adding up and adding up. I didn't even go. I have like a normal 10-minute walk thing that I do every day that I didn't do yesterday for the first time in like forever. I'd have to check my like tracker thingy. Um, I kind of made up for the walk. I already walked earlier today, and I technically made the video yesterday, but today I'm feeling a lot better, so I just really wanted to go all in. So we're gonna go and do all of the docs through to where I have reached today, so which was body updates. So I wanted to do that, and then on my own today, I was hoping to finish up the user guide today as a whole, and hopefully I'll be able to go through the advanced user guide tomorrow. We'll see, and actually go through the entire thing. We'll see how the video turns out. Tomorrow, I'll probably do a full video of the entirety of the user guide. Um, we'll see how that goes. Uh, Basically, I want to build to the point where I'm doing a full, like, extremely large video that just goes through the entire thing all the way through to how-to recipes. I don't know about how much I'll do in the how-to recipes. I think deployment is where the real useful information is, and how-to recipes is just like boilerplate code you can use for lots of stuff. So I might still go through some of them. Let's see. I'm not sure. Sorry, there was like little. My chair has a built-in like leg rester thingy, and it was like sticking out and getting into my jabbing into the back of my calf. So I was just trying to like shove that back in. Um, yeah. So let's get started. We'll do a long ass video, and also I'm gonna let's see how much I remember to actually do this. I'm going to try and write things out because there's a lot of repetitive stuff in the docs because I feel like it's, sorry, in the guide, because I feel like it's meant to be read as a one off sometimes. Like if someone comes to this and is like specifically looking up cookie parameters, right? And then they read about cookie parameter models, and then there's like, it has a lot of similar code and ideas as like the query parameters page, for example, um, but just specifically for cookie parameters for someone who's looking that up. So I'm going to try and generalize those concepts and create like a nuanced, complete uh, guide thing. So I'm just going to try to draw that out. Let's see how this goes. But this is going to be the attempt today. So we're going to start here. I'm just going to keep an eye on my battery because I am running on battery power. I have a um, really large power bank that I'm trying to charge as fast as humanly possible so that we can keep going through this video. If it falls off and gets a little too long, let's see how this goes. So today, so we're starting with Python types intro. So the reason Python types are relevant, right? So what are Python types? Essentially, you have some function, right? It takes some parameter x, some parameter y, does some stuff. I'm just going to type pass here, or write, and then return something. Something computed. Now, inherently in Python, we have what is known as there's no type validation, not what is known as. There isn't no inherent type validation. Essentially, types are essentially inferred at runtime rather than at compile. And compilation, even for Python, is a little funky because it's like people think Python is a fully interpreted language, and that's not entirely true. There's essentially a step of compiling to bytecode, and then at runtime, that bytecode is interpreted. That's why you'll see a underscore underscore PyCache folder usually in a Python environment. If you've run some code in it, that's like the compiled bytecode. And if you don't make any changes to your code, it actually reads straight from the bytecode. It doesn't compile to bytecode. Again, so there's no inherent type validation, but there is such a thing. I think this came out in a PEP a few years ago. What a PEP is, I'm not even getting into what a PEP is, but there was a PEP a few years ago. Okay, I'll slightly get into that. The way I think of it, because if we go into what exactly, you know what, fuck it, let's ask AI. What exactly is a PEP? Just gonna, let's see if, oh no, I'm not, Python. Yeah, politically exposed person, this is not that kind of channel. Python Enhancement Proposal is a formal design document that provides information to the Python community or describes a new feature for Python, its processes, or its environment. So there you go. Okay, that's exactly what it is. I have not internalized that, but I'm just going to read it out. So there was a PEP that came out that introduced type annotations. And this essentially provides IDE support. So taking this example, bringing it down here, that would look something like def x, int y colon int returns type of return. I'm too lazy to write an actual type. So some sort of type of return, that'll be the syntax. Is it after the colon or before the colon? I don't remember, but that's really irrelevant right now. We'll see in a moment. So this essentially gives you IDE support. So when you're typing, if you wrote a function and you defined using these type annotations, it's return type and this, right? And you want to chain, for example, this function's return value, and then instead of actually assigning it to a value and then manipulating that returned value, you want to manipulate it right there, right? You can go dot, like for example, if the return is a dict, you can go dot the key of the dict. Actually, you can't do dot keys in Python. It's for, you'd have to use the square brackets, but whatever, you know. And you want to like add an item to that dict, and then you want to assign that whole thing to a variable, right? You could do that, for example. But if you don't do type annotations, the IDE doesn't know what type you're supposed to be returning, and so you wouldn't get that support. And it's also like, if you have mismatched type returns or any confusion, that can be ameliorated as well, right? If you write a complicated function and you intend to return something and you didn't return that, you return something else, that can cause issues. So just to be clear, you can do that. Why this becomes valuable for FastAPI, I'm just gonna, oh, that's small. I'm just gonna erase all this. Oh. Okay. I thought there was a fancy shortcut to switch, but FastAPI is essentially a framework for that helps you build APIs. Duh. Right? Right? Now, a function, if you hit up some URL endpoint, URL endpoint, that's going to hit up your FastAPI server. your server that you've written in FastAPI, right? A URL is also known as an endpoint, right? The data it receives it is broken up in a couple of different ways. There's header parameters, query parameters, body, etc., etc. We're not, I mean, we will get into that over the course of this video. But before we get into that, the essential point is that data, you use this endpoint to give data. That's essentially what APIs do. And I'm getting a phone call from my dad. I'm just going to pause this recording. Okay, coming back to this. So essentially, an endpoint is a way to find a server. So you have, if this server will have some sort of domain, and it will have multiple endpoints, right? So just going to the domain, that's one endpoint. That's the root endpoint usually. And then there's, I don't know. Oh, I don't know how that, oh, I know what happened. I forgot about that. I had a feature where you can double tap to switch. Domain slash user slash some ID will get the user with that ID. That's an example, right? I don't know why I did that. I forgot that this is free form, so I can move around. I was still thinking like I was doing this in notes. And then that data will be, oh man, I hate this feature. Can I do it from any point? Oh, it doesn't matter how I do it. So some data is returned usually, right? I think this would be technically considered RESTful API, maybe? No, because RESTful isn't just about data exchange, it's also about it being stateless. So basically every API call needs to have all of the information. Instead of just like, for example, if a user logged in on a browser, right? The browser would actually have something called a session ID that was handed from the initial login, and it has to pass that session ID with every API call to make sure that the receiving server knows that the user is already authenticated, because otherwise it just won't work, and it has to do that every time, right? So that's RESTful, but this is more like generically what APIs over a network are, right? And I use that very specifically because you can have, technically everything is an API. An API just stands for Application Programming Interface, right? So almost any Python library you install is an API to some deeper code, right? If I use like pandas.read CSV, that's not, that is me using an application programming interface. Read CSV is the interface for the code that read CSV runs, right? I could just write that code myself and still read a CSV without ever using pandas read CSV, right? That's an example. So I'm not talking in that very generic context, specifically over the network. What happens is that essentially when you're transmitting data over a network, commonly a type is used called JSON, which stands for JavaScript Object Notation. And it essentially looks like a dict in Python. There's like curly braces, you have some key and some value, and sometimes it can be where the value is a list of values, etc., etc. It looks like a Python dict, but the key is for it to be transmittable is actually this whole thing is a string, right? It's literally just a string being passed over the network. And so a large part of what servers at either end, the person who's sending it and the person who's receiving it, is making sure that the string data gets turned into the valid data type before continuing any processing, right? Whatever an endpoint needs to do. Like for example, in the domain user ID, we're just getting a user, whatever. But there could be like many other things, right? So if we're using the OpenAI API to initiate a chat, we should get some text returned along with some other metadata maybe, but whatever. So that is where FastAPI comes in. So FastAPI uses what we discussed as the type annotations, right? Utilizes that information that was essentially originally meant for just editor support to actually validate type annotations, validate incoming JSON, and also in combination with something called Pydantic, which is a library for validation of data. It's just a library for validation of data. Also validates the serialization of the data into JSON on the output. I'm getting really annoyed with this. I'm gonna switch off this capability. I had it switched off for the longest time because I initially had it switched on, and then where is my app? Oh, there it is. Hover effects, double tap, off. I'm just gonna switch that off. It's so annoying. I originally had it off. No, actually, I originally had it on. I switched it off, and then I saw that there's a capability just so that it only does it on hover. So I switched it back on cautiously with that, and I keep screwing it up. So I'm just like, nah, it's just gonna go back to off. I'd rather just switch it manually. It's a little bit more irritating, but whatever. I'm just like used to like moving and playing around with my pencil and tapping it and all that nonsense. So it's just not good for that. So type annotations. Oh crap! I have to switch this back. Type annotations plus Pydantic models, which we'll get into more details of what that is. Helps validate serialization to JSON. Okay, so type annotations are an important concept, essentially, to understand FastAPI, to make use of the power of FastAPI, right? Because FastAPI has, from a performance perspective, it provides async and stuff like that, and that's really important as well, like out of the box. And then the other part of it is incredible speed of development by using as many near natural Pythonic things to do. So that's why this document opens with the Python types intro, and I'll just get into that very quickly. So when you give, this is just showcasing like a regular function. This function does something, whatever. To annotate the input types, you put a colon, and then you put a string, or whatever data type, string, int. All your Python basic data types are supported. So list, int, string, whatever. So if it's a list, you could also go list and then string. If you wanted to be like, okay, this is going to be a list of everything that's a string, right? Or a list of tuples, which will have 3 strings or something like that, or an int and 2 strings, some bullshit. anything, literally anything that you want, you can put it down here, right? And then it knows that this function is supposed to receive this data. It's going to be important for FastAPI, but also really important for editor support. So it's good habit to get into because it's going to be great for like actually developing stuff as well. But even before you get to that point, like it's good to know. There's also things for return, and you can. These are just examples of all the things you can stir in, float, bool, bytes. Generic types with type. There are some data lists set in tuple, and the internal values can have their own type too. These types that have internal types are called generic types, and it's possible to declare them even with their internal type. So all of these data list, all these data types, they're called generic types because they have other data types inside of them, and you can define them, right? So with the dict, you'd have to do like the square brackets and be like string int something like that, right? So to say that the input is a string and the output is an the key is the string and the value is the integer in that dict object. So this is a small Pythonic thing to be pointed out. Essentially, from 3.9 onwards, you can just use colon. You can use these generic types directly when declaring it. So as you can see here, list stir, really straightforward. 3.8 or previously, you'd have to actually import list from typing directly. Well, I don't think typing used to be a thing before 3.8. So let's just say for 3.8, you had to import list separately from the typing module compared to 3.9 onwards. Though I'm pretty sure that while all of this is deprecated, it is available in 3.9. Not deprecated per se. I think it's deprecated in the sense of like, I guess it is deprecated. I don't know. Could be deprecated. I'm not sure about the deprecation status of that, for how long that'll be supported. I don't know if it's been officially deprecated or if there's been a promise that it'll just forever be supported. I don't know. I'm just gonna let that be. And yeah, this is just a distinction of what this means, that items is going to be of type list, of which each element is going to be a string. Boom, done. You can set up tuples and sets now. Remember, tuples are not mutable, so you can also define how many values the tuple would take. I don't know what this means if I want to do a type annotation where I'm like, I am accepting any tuple of any size. I don't know how that would work with type annotations. Tuple type annotation any size Python. Let's see. Oh. Okay. I remember this ellipsis thing somewhere else as well. So essentially, if you want to define a tuple of arbitrary length, but you know the type of each element in that tuple, you can do that, and then just ellipsis. Or I think you can do type, and if you don't know what the type is, or there's going to be multiple types, you can just go any. I think that works. Oh, that's pretty much it. And if you know the type, you can just put that instead of any. So yeah, so you can do tuples, you can do types, sets, dicts. You'll have to do both, as mentioned earlier. Union. So union is important. So here's a 3.8 code, and it's code that I wrote in my very first video. Well, not the literal first video in the channel. I have some old gaming videos that I'm not talking over. But in my first video, I was trying to, like, I did dot products, and dot products was super easy, so I just kind of decided to challenge myself to do it with perfect type annotations, which was mildly irritating at times. Um, you can, so when you use union, you're essentially saying this thing can be either this or this, right? Or any arbitrary number of things. Um, and in 3.10 onwards, which I didn't realize at that time, and I was using 3.12, so I feel like an idiot now, you can just use the pipe operator to say this or this, right? Really straightforward. Now, if you want it to be potentially none, you can say that. So that's where optional comes in 3.8 or above. Apparently, yeah. So there's optional. So if you say optional string, it just means that that string could be string or none. It doesn't actually make the parameter itself optional unless you give it a default value. So here there is an assignment of a default value none. Therefore, it actually becomes optional. But optional itself is literally just a synonym for union type comma none, right? And once again, in 3.10, we can just use the pipe operator. So that's just, I really dislike optional because it makes it sound super confusing, honestly. And also, yeah, so the same thing, optional, it's not optional unless you set a default value. They're just pointing that out here. And here also, just because we give, so this example is kind of tricky, right? Because there is no default value assigned, name is still extremely needed in this thing. And that can be none. But you need to explicitly pass none. Otherwise, it's going to throw an error. So just letting you know. So these are the generic types. I don't understand. You can use the same built-in types. Using the generics, union, and optional, you can use a vertical bar to declare unions of types. That's a lot better and simpler. Okay. I was like wondering why is 3.9 and 3.10 a different size, and I just realized it was because it's a sentence. It's like, what's going on? So classes can be types. Fair. Remember that when you put the class name as a type in a type annotation, remember that when you actually pass an object to that function, you're passing an instance of that class, not the actual class itself. Some basic Python stuff, but that's what they're gonna be talking about. See, notice that it means one person is an instance of the class person. There you go. Pydantic models. So it's a library that helps with data validation. I actually don't know what. I mean, I'm guessing you can use it with other frameworks like Django. So I don't know why this is a separate library, because I feel like these two communicate very closely with each other. But anyway, so Pydantic is a library for data validation. You need to install it. It'll come installed with your standard FASTAPI install, or I believe it's a requirement. So you can essentially define the data shape, and you can be like, this is the data schema. Actually, I wouldn't call it shape because I don't like the word shape. But you can define the data schema, and you can create user blah by passing in a dict that works, right? And then you have this thing, and because in here you've defined this with the type annotations, it'll throw an error. Not that useful, except for applications that need to verify this at runtime, right? If you're just doing a regular script, I think you don't need Pydantic, or maybe you do. I don't know, actually. I would maybe I'm being wrong. I actually don't know what are the other use cases of Pydantic other than for developing APIs and something. There must be something. I don't know. It could be like if you have a library where something some sort of function calls another function in that library, um, and that second function can be passed with, like, for example, in one particular situation, in one particular place, you can pass a list or a tuple, but that secondary call to the secondary function will only work with a list, not a tuple. So you should strictly define it to be a list and make sure that gets validated um, with Pydantic, maybe something like that. I don't know. Um, I actually don't know whether FastAPI does the validation or Pydantic. I actually am. I'm thinking about this. That's very fascinating, but I don't want to get into it right now because. So, there's a little aside about why I've been so gung ho about reading the docs for FastAPI and not jumping down the normal rabbit holes of like, oh, I want to learn Pydantic and this and that I've talked about in the past, is because I know learning Pydantic or even the OpenAI API, which are both things that are going to be part of the project, and I'm going to try and record me building this, or at least pieces of it. Um, that's how do I put this? Like, I can go straight to the docs and learn things from like just the SDK reference for Pydantic and also for OpenAI, because I've used APIs before, so I know how they work. So I don't need to like read the full on guide. And similarly with Pydantic, I've used data relevant libraries before, so it's just like going to the reference and understanding everything it does, or understanding the different functions or capabilities just like by skimming the reference instead of actually like reading it like this. And I could have done that with FastAPI as well, if I'm honest. But if I did that, I know there's certain key aspects as to how APIs are designed. Like, I know enough to know that I didn't know what APIs should be designed like, because APIs aren't like scripts. They're actually very social things, right? They're made to be interacted with other people. So the design of an API is needs to bring that into consideration. Jumping a little ahead past, I'm like spending so much time here. I'm still on types. Um, into like the verbs of API, like the get, the put, the update, etc., delete, right? They have social norms associated with them, even though anyone can pass whatever they want. A fast API won't stop you, and technically, if you're building your own, there's nothing stopping you from using a verb in a particular way. But there have been such strong social norms around that people don't do it, to the point where many APIs out there will not support it. For example, sending a body or needing a body for a get, right? If you do a get request, and for that get request to process appropriately, you need a body, that won't work because some intermediaries just won't support that, because the norms around using get means that you never pass a body, and that's why they never implemented that. So it's weird, and there's things about that from a developmental perspective that I didn't know. So I know once I go through this guide, because I felt that this guide was very comprehensive and was willing to teach you things outside of just Fast API. Was why I wanted to read this entire thing, and then it's like building the API along with all these other learnings of Pydantic and the OpenAI SDK and things like that. And I also didn't want to turn into a vibe coder because I feel like that's like a sure path to disaster if you don't really know what you're doing. And in this situation, I don't. I feel like eventually I'll start using agents or whatever once I'm really good enough and really know what I'm doing. But if I use it now, I feel like I'm just asking for disaster because something will break and I don't know what it is. Anyways, continuing on, type hints with metadata annotations. So you can basically annotate it as interesting because you can annotate something as you pass in the type, and then there's just some metadata that you pass. And I don't know how other libraries use it, but essentially, in combination with Pydantic and FastAPI, both use it for inference of parameters. So, for example, if a parameter is a query parameter incoming, sorry, let's not do query parameters because honestly, if you don't give it any type annotation, a parameter is inferred as a query parameter if it's not already in the path URL. We'll get to that in a moment. But let's say you are getting a parameter that's a body, right? If it's not a Pydantic model already in your code, it could be inferred as a query parameter. Unless you annotate it, if you annotate it using this from the typing module, you can annotate it with the type, like the literal type, and then give it this function that FastAPI provides that for some reason gives it the metadata and validates it as like, okay, this is to be read as a body parameter. If I get this, this is a body parameter. Okay, no problem. And you'll see that again and again in multiple places. I could have gone back to drawing all of these things that I've just taken random asides on, and I have just chosen not to. Let me see if my... Yeah, okay, my recording is still going over there. That's fine. So, man, I'm really hungry out of nowhere now. I'm gonna pause and eat a cookie or something. Okay, I paused and I literally had a cookie. Let's get back to it. So, long story short, that's where annotated will come in handy, and we'll show you how that code works later on in these talks. That's pretty much why but I've explained why we need type annotations, or why we should care about type annotations when we're working with FastAPI, because it makes our life extremely easy in terms of validating the incoming data, and just reduces boilerplate code by a significant amount. I don't know if Django does the same thing, or you can do it with Pydantic or something like that. I'm not sure. But here it's extremely important. So next thing is concurrency and async await. So I've explained this multiple times before, and this whole page is like, there's very little code here. So I'm just going to ignore that and just completely talk over this page, because I'll just give you everything regarding this page and the next one, which is environment variables and virtual environments. I'm going to go through all those pages like here. So we're just going to... I'm just going to actually save this. Rename. Y type annotations. Fast API. Fast API. There you go. So I'm just gonna save that separately. I'm just gonna see my KYC dogs. New. Oh. Make a scene. Add scenes to easily jump to regions of this board. Huh. Okay, well, that's something I'm curious about. I'm sure there's like a 2 hour freeform, everything freeform can do video in my future someday. Um, but let's get back to the main business. I'm just gonna make sure, yeah, the recording is still going. So there's a concept thing here that needs to be understood. So concurrency versus parallelism. Right? I'm just gonna try and showcase this with a simple diagram of a couple of lines. So parallelism is the easiest one to explain. It's literally two things happening at the same time. This is a thread, CPU 1, and this is another thread, CPU 2, and they're doing things at the exact same time. That's parallelism. Concurrency is a single thread used to work on multiple tasks. Task 1, task 2. What this is essentially saying is in task 1, I moved up to this point here where I had to do something that takes time. So I'm just waiting. And so, since I'm waiting, I moved over and did task 2. I had nothing to wait for that. Once I came back here, the thing I was waiting for is done, so I can just continue on and finish the task. So it's a single thread that is doing multiple tasks, right? And just hopping to the next task while it's waiting. Just gonna do this, clean that up again. I'm gonna do it like this. Just denote thread 1. Simple. So, in Python, technically there's something called a global interpreter lock that doesn't allow for applications to be concurrent per se. That doesn't allow applications to be parallelized. There's basically only concurrency. And how concurrency works. In Python, you're going to use the words async and await. And there's a weird chicken and the egg problem here that is solved if you get deep into async IO, which is another library I want to get into, but I'm not going to get into because honestly, with FASTAPI, you don't have to worry about it too much. There's like a collector and you have to explicitly initiate the event loop and things like that. We'll get into what an event loop is because that's actually kind of relevant to how this works in FASTAPI. But essentially, any function that you define as async def, right? And then some function. I'm gonna actually clean this up and write it. Give me the big eraser. Okay. Let me switch back. So any function that you have that is defined with async has to have a part await some IO blocking code, because that's usually what it is. Oh, I forget. blocking code. Return. And this causes a chicken and an egg problem because you can only call async functions from something that is itself an async function. So because you can only await functions that are async functions. So some IO blocking code async function. So that's how it normally works in Python. But that's not something we need to worry about too much because you can just that was the first drag I had on this entire time. Let's see how my battery's doing. Not too terrible. So that is something you don't need to worry about with FASTAPI. Because with FASTAPI, what you do is you have to worry about three things with the routes, not with with the routing functions or with the path operator functions, as they call it. So as we discussed about endpoints, you have some endpoint. Let's say some endpoint. Right? We're just going to call it endpoint, right? You say at app.get. So we know this is a get endpoint, okay? Because remember, get is one of the verbs, right? And app is essentially an instance of the FastAPI class, right? And that's how you start up the server. That's just how it works. And then you write async def, right? Now there's a couple of rules to remember here, and I'll explain why. If you have some blocking code, I'm going to ignore IO blocking, but generally any code that's blocking is usually IO blocking code. IO meaning reading from a database or from over the network or writing something. You know, these things, like things that need to be written or read from disk, will take some time. And that's why it's called IO block, input output. But some blocking code, because you can do sleep, async sleep, for example. Some blocking code that is also an async function. And you, because it's an async function, you have to await it, right? That's one situation in which you use async. And then you return. And then you have this if a function get endpoint let's call it endpoint non-async. Let's just call it that, just to make it different, right? You do, and this, by the way, the little thing with the at is what's called a decorator in Python. So a decorator is a function essentially in Python that takes your function as its input and outputs another function, right? What I presume that this function does is it basically gets the data from the endpoint, and then, as we discussed earlier, does the validation and then passes it to this to your function. So your function becomes embedded in that higher level function. I think that's the function that is returned essentially in this case, but that's essentially what a decorator is. I don't know if it's always a function that's returned. That's something, you know what, let's just look it up. Does a decorator in Python always return a function? Yeah, does not always have to return a function, although in the context of function decorators, it typically does return a callable object, which is most often another function or wrapper function. With the add center is callable that takes the decorated function as an argument. A common pattern is for this decorator to return a new function that encapsulates the original function. Class decorators can also be applied to classes. In this property, the decorator takes the class as an argument and can return a modified class or even a completely different object that replaces the original class. For example, built-in property decorator is implemented as a class and returns an instance of the property class, not another function. While returning function is the most common scenario for function decorators, a decorator could technically return any callable object. Returns an instance of a callable class, not a pure function. While the most frequent use case for... Okay, anyways. Technically, they don't have to, but whatever. For our purposes, they return a function. And you don't have... And you have some blocking code in that function, right? But it's not an async function. So some blocking code, not async. Okay? And then you return. This is how it's supposed to be, right? Obviously, you can't, even though it's blocking code, you can't actually like do that blocking code unless you can't await blocking code that is non-asynchronous, that wasn't defined as an asynchronous function, right? So in that case, you put def. So that is how you would do it in Python intuitively, right? Here's the weird stuff. If you have a function that is non-blocking completely, like it's not speaking to any database, there's no reading, there's no writing, there's no nothing, right? It's just like, for example, if it's a endpoint that takes 2 integers and adds them up and returns it, it's not talking to anything. It's like a very dumb thing. Like, why would you have an endpoint that does that? But you can. Endpoint non-blocking. Let's call it non-blocking. Right? In this case, you want to use async def. Return. Now, why does any of this make sense, right? The first two kind of make sense because that's just what you have to do in Python. Why does the third one make sense? Because essentially there is something called an event loop. And essentially the event loop stops whenever it's doing a task. So there's, for example, task 1, 2, 3, right? We start by doing this, then we transition to this while we wait here. Then maybe we go to task 3 or back up to task 1, doesn't matter, as we wait here. Right? And then we eventually go back to task 1 and finish it. Finish. Right? And we finish it, we come back to 2. Sorry, like that. And then we wait. While we were here, I'm just like, never mind, I wasn't drawing any of that. I don't remember from when I haven't been doing this. Oh yeah, I went to look up decorators and whether a decorator returns a function or not. But essentially, there's an event loop, right? And there's task one, task two, task three, right? And this is how it's happening, and you just finish task one over here. While you're working on task two, a new task is added here, right? The task was finished, but now a new one has taken its place, right? And so when this finishes, it can go back and grab another task. So that is the event loop, right? Let's say there's task, 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 and a task will always, once it's finished, it's going to be replenished, right? So the event loop is just choom, choom, choom. That is the event loop, right? There's continuous stream of async tasks, right? Now, which task gets added to the event loop and which is queued to be added to the event loop, and all that stuff is way, way beyond what I understand. But this is essentially what it is. So what FastAPI does in this situation is essentially, in this situation, is it takes it and assigns it to a thread. Okay, and there's a thread pool. There might be 4 or 5 threads available, right? And I know that's different from the global interpreter lock. That's slightly different because global interpreter lock prevents parallelism. It doesn't necessarily block access to another thread. It's just that then that thread is the only thing that's running. So, though there is a way to overcome this using Gunicorn, which Gunicorn can make multiple UVcorn workers, and UVcorn is what launches FastAPI, essentially the FastAPI server. So that's the way you have true asynchronous parallelism when you actually deploy, but that's a different story. So here, over here, essentially what happens is this function, async def, is running on the event loop. Runs on event loop. And even though so this is executed immediately on the event loop itself. And I don't mean like literally immediately, but when it's time. When it is picked up, it just finishes and then it gets tossed back to we go back to the event loop. But in this situation, this would break the event loop, essentially. Because the event loop can only have asynchronous tasks. So this code is assigned to a thread. I literally drew out a line because in my head it's literally a thread, which is fun to think about. Is assigned to a thread, and then this entire thread is awaited. Right? Which is why even though you have nothing to await in this function, it is recommended in FastAPI to actually just run it as an async function. So because it's to make sure the event loop isn't broken, what it will normally do is actually, if you assign this particular function, I'm just going to zoom in on this, the non-blocking endpoint, if you define it as a regular function instead of an async function, what it's going to do is it's going to assign it to a thread and then await that thread instead of just awaiting the function directly. So that overhead of assigning the thread actually makes this a bit slower. So that's the recommendation. You're not going to blow up the world if you don't do this, but that's the recommendation. Okay. Oh man, this is actually a fairly large little thingy I drew up over here. So that is why you need to understand concurrency. I don't think there's much else to be said here. I'm just going to skim through this super quick. It's very fast. Okay, yeah, technically coroutines is what they are called, what an async function is called. The dependency, so we haven't gotten to dependency injection yet, so we'll do that some other time. Sorry, I was just took a break drinking some water. We're not getting into dependencies yet, so we're just going to skip that. Environment variables. I'm just going to save this first. Rename. Async. FASTAPI. Now we're just going to create a new one. Okay. I need to pause the recording because my mom is calling for the caregiver and she's rung twice. Alright, just going to resume recording now. Environment variables. So this one's actually fairly simple. Whenever you're running code, there's an environment. Okay? Everything the code needs, libraries. Actually, I'm just gonna clean this up. So we can pretend that all the white space, no matter how far you go, is the code's environment right now. Everything it needs, libraries, primarily libraries, runtime, Python 3.12, compiler, and this thing called variables. It lives somewhere in the environment. So on Mac, can you show you this? Echo $path. So path is a very common, very important environment variable. So this is my path. So the path variable essentially is used by many programs to the path variable is used by many programs to execute to find a program to execute, essentially, right? It'll just go through all of these directories that are separated by a semicolon here. You can see that semicolon over there. To find where do I run program. Someone types Python hello world or whatever. It's going to find the Python execution binary in this path. So that's an environment. That's one of the most important environment variables. This is not something that's actually relevant to FastAPI directly, but it's extremely important indirectly in terms of building APIs in general, because this is a way you can pass environment variables quietly or secretly. How do we do that? Right now, our code's environment is everything, right? Or more literally, everything on your computer. We can encapsulate that and be like, hey, this directory let's say the directory is this circle. I'm gonna dismiss this error and this error. This directory has everything you need: libraries, runtime, environment variables, everything. Don't look outside. Okay? Now, it breaks into two things. So your libraries, your runtime, your compilers, this can be controlled on your personal machine using something like UV or pip venv, virtual environment. Just essentially you'll see, let me see if I can pull up. Right here, there's a .venv folder which has all the libraries, and UV also manages my Python, so it knows which Python version to use, right? Pip can't be that fancy, so I would strongly recommend UV. But yeah, this, along with everything else, it's best to do in something called a Docker container. So this is something that we'll probably talk about in another future video, because one of the things is deployment, and deployment has stuff about Docker, I'm presuming. Or has to, at least, because Docker is intensely important. And what you could do is, when you spin up a Docker container, to pass variables in. Obviously, you can also set up the Docker container to pass in everything, and you will, but the variables are important. Why? Because you can keep these variables secret. When you're spinning up the Docker container, you can set it so that the environment variable is destructed after it's used. You can do other fancy things to hide the environment variable. And it's honestly going to be very difficult for anyone to actually look into the layers of Docker or running Docker container. What is much more easy and likely to happen is that if these environment variables were kept in the code directly, for example, like an API key, someone who manages to get access to the code on your GitHub repository or whatever gets your API key. So that's important for security. This is like more general thing about what variables are, what an environment is. But that's essentially what this page is. Create and use env vars, right? You can go os.getEnv. You can also do os.setEnv. So from Python, you can create an environment variable. And here's talking about the path variable. That's how something like UV usually, or pip venv usually allows you to isolate like the installation and stuff like that, is by actually appending to the path at the very top, so that whenever the code is running from that terminal, it'll always go to this path first and never go to the other paths, and then replace it with the original path once it's done. That's actually a presumption. I'm not 100% sure about that. So virtual environments, we've already talked about what a virtual environment is, and we've talked about UV and things to. Okay, yeah. So this is generally good advice about adding a git ignore file. Um, we can get into that at some other point if people need. But there's really nothing new here as to. It's just further explaining the issues. So yeah, this is another issue. Is generally, I was speaking about it from a security perspective, but from a development perspective, even this is extremely important. Why? Because if you're working on multiple projects, which you probably are, I mean, unless you're an absolute beginner, but you're probably dealing with multiple projects, um, which would have conflicting dependencies, which can cause issues if you're just installing everything to your global environment. So, where packages installed, blah blah blah, inside the virtual environment. Yeah, so the virtual environment is just a directory, as I showed right here. .venv. It has the bin, the library, the everything. Yeah. So I managed to encapsulate both environment variables and virtual environments in one document. So I'm just gonna save this before I continue. I'm just gonna name it environments. Okay. I'm gonna create a new page for later. I'm gonna ignore that for now. So, moving into the user guide. First steps. So, remember in the app.get, this is exactly what that's showing. First, you have to initiate an instance of FastAPI, assign it to a variable. App is a common one, makes perfect sense. And then that class has access to these functions, which are become the decorators, and define your endpoints. So you'll have @app.get, update, delete, all of them, all of your general RESTful API verbs. And here, this is just the root, and they're just returning message hello world. So that's what this endpoint means. It's literally, if you go to facebook.com, nothing else after that, just facebook.com. That's facebook.com's root endpoint, if you will, or root URL, whatever you want to call it. You can just run the server pretty easy, FastAPI dev main py, or you can throw UV behind it to have UE manage the UV manage the environment, all that stuff. FastAPI is nice. It gives you interactive docs. So if you just go to the running URL and hit /docs, it'll just give you interactive docs, so it allows you to see the entire API and how it works. No problem. Same thing with Redoc, which is another API, interactive API documentation interface. Both come pre-bundled with FastAPI. I don't know why. I don't know what the difference is between I've always used Swagger. I'm just gonna Google Swagger v Redoc. Are both popular tools, folks. Interactivity, design, 3-column layout, navigation, documentation examples similar to popular like Stripe and Twilio, enhancing readability and navigation. Features best for public-facing API documentation. Okay. So apparently Swagger is better for actual developers, and Redoc is better for public-facing endpoints. I don't know. I'm not going to get into it. So this is kind of how FastAPI generates the interactive docs, as we discussed about the type annotations. Helps generate what is known as the OpenAPI schema, which is then what is read by the interactive docs, and then that is what is used. what is shown in the interactive docs. And OpenAPI schema is essentially just a set of standards of how how APIs are meant to behave and connect with each other and talk to each other. And there's a lot of verbs and things like that. It looks something like this. You can go to it by just going /openapi.json. You can read it, see all the paths, etc., etc. So this is just a quick recap. This one's pretty straightforward. These are some of the available options or verbs in the operations and path operation function. The add something syntax is a decorator. We've talked about decorators. Define the path operation function. Yep, this is our path operation function. It's as simple as that. This is the actual function. This is the path. This is the path operation, get. And this is the function. No problem. Pretty straightforward. And return the content. It's really super simple. Path parameters. So one of the ways APIs get past data is in the URL itself. So if you do /item ID, or like I showed earlier in, let me see if I can find it. I think I did it over here. Domain/user/ID over here, right? So I could do that, and then user. It's similar to this. So you have to find the domain, but after that it's item/item ID. And if you put the curly braces in, it basically allows FastAPI to understand, like, oh, okay, I'm expecting a parameter here in the URL path or in the path. From here on, I'm just going to use the word path. And that's actually the parameter for my function, right? Boom, simple. That's what a path parameter function is. If you type annotate it, that's great. It gets added to the OpenAPI schema, so you can see it in the interactive docs, and it gets data validation as well. Conversion and validation. There you go. That's the correct word. Otherwise, everything's a string, so you have to match that manually, which would be annoying. It's just showing you what it looks like in the docs. No problem. All the data validations performed under the hood with Pydantic. Okay, awesome. Order matters. So this is an interesting thing. If you're having similarly named endpoints, be careful about using them, because, so for example, these are both path operation functions with users. This one, user slash if wait, let me see if there's, I think they have another oh, no, they don't have another example of this. So basically, if users/user ID was written at the top instead of user/me, right, then what would happen is user/user ID would be the endpoint that would be always hit even if you pass user/me, because it will presume that user/me as a parameter, as a user ID parameter for this first path. So you have to be careful, because the ordering of the path matters for that reason, like in the code. I think that has to do with Python being interpreted, and maybe that's why. I'm not 100% sure as to why that is the case. Probably that's why. And it can cause, so, but it wouldn't be an issue, for example, if you either changed the URL or if you changed the verb. So if you changed the verb, it would never look at this. If, for example, this became a post, which it wouldn't. Yeah, so just a little simple thing. And that's why user/me is put above user/user ID, because if someone passes me, you want it to match with this path and not with this. And this is just another example of ordering matters. This second path will never, ever, ever be used. It'll always be this one. So no worries. Predefined values. So there's things called enums. Enums are enumerations, I think, technically is what they are called. And it's essentially just a grouping of predefined values. And you can use them in FastAPI, like you can use anything. And it can also be passed as a type annotation. So if you create a class str, enum, So string would tell FastAPI that all the types of this will be of type string, and then enum is what helps it be predefined, and you can just pass that as a type. So that's pretty neat. API docs will be able to know that the values must be of type string, then create class attributes with fixed values, which will be available as valid values. Boom, simple, pretty straightforward. Since Python, so apparently enums have been available since 3.4. So if you want to know, pretty straightforward. Nothing really groundbreaking here. I wonder if you could do this with Pydantic, which I don't think they've introduced yet. I think it comes in request body section. But yeah, by inheriting string, the API also and create class and which will be available values, and then declare a path parameter, then create a path parameter with the type annotation using the enum class you created. Okay. Check the docs, and if you check the docs, you'll see that these are the valid input points. The interactive docs can show them nicely, so that helps out. Working with Python enumerations, and these are just different ways to access model name. You can go model name.value, model name.alexnet. Yeah, it's an enum. Not much to say there. I'm just gonna move past this. It's just all about how you use an enum, which is straightforward. This is kind of interesting. So technically, you can't add paths of a URL to an endpoint as a parameter. Technically, that's not something that's feasible or valid in OpenAPI, but FastAPI will not stop you from doing that. So if you want to pass something as a path, you can just do :path and then type annotated as string, and you're done. So that's path parameters. Query parameters are basically anything that you don't define as a path parameter. By default will be interpreted as a query parameter. That's essentially all that is. So for example, here in this function, Q is going to be a query parameter versus item ID, because item ID is defined here, and Q has been type annotated to be a string or a none and assigned the default value none. So Q, in this case, the query parameter, is optional because the default value is assigned. And valid types, if Q, the parameter is passed, is string or none. So yeah. Query parameter type conversion. You can also declare bool types and they will be converted. Okay, yeah, you don't have to worry about that. The neat thing about bool is FastAPI is very good about interpreting multiple versions of bools. So one, true lowercase, on, yes, all caps, true. I think they would all be accepted. So I think that's fine. Uppercase first letter and uppercase, etc. Your function will see the parameter short with a bool value of true, otherwise false. You can define multiple path parameters and multiple query parameters here. Q and short are both query parameters, totally fine. This is, what is this? Required query parameters. Yeah, so basically if you don't assign a default value, it will be a required parameter. Pretty straightforward. So basically, unless you define a valid my battery's about to die. If you don't define a default value, you don't get a parameter. If you don't define a value, you will get that parameter becomes required. Sorry, my brain was farting there. My battery was super low and I was like, okay. So pretty straightforward. Nothing really new to say, and a lot of these are going to be very repetitive. So I'm going to start speeding through these. Well, actually, we need to talk about Pydantic. So Pydantic is your data validation library. Um, you can base model is there from Pydantic. I'm sure there's more advanced model types to give you certain other types of validation. I don't know what that would be. And if you create it, you can do type annotations within that, and if you allow this thing to be type annotated as this, then it will be interpreted as this route, this path, items, and this verb, post, is to be interpreted as a JSON body with these items, and then FastAPI will do all the validation and everything like that for you. That's essentially what there is. It's just describing that you can set up these default values, etc., etc. It's totally chill. You can give the full thing, or you can just ignore the defaults and it will be created for you. You have to declare it as a parameter for it to be interpreted as a JSON body. See here, read the body of the request as a JSON, convert the corresponding types if needed, validate the data, give you the received data and the parameter item, generate JSON schema definitions for your model. You can also use them anywhere else you like if it makes sense for your project. Those schemas will be part of the generated OpenAPI schema and used by automatic documentation UIs. So just by doing this, you've accomplished a lot in terms of data validation and documentation, as well as just making your development life easier, because it'll give you all the type annotations and stuff. Editor support, boom, boom, pretty straightforward. Using the model, you can just do the dot syntax to access items in the model. You can dump it to a dict if you want. You can just use the model like a regular class, and you're just playing around with the attributes of that class. You can just do whatever you want. Request body and path parameters, so you can do query parameters and path parameters. This one's easy. This one's been defined as a Pydantic model, and so this item is understood to be the body, a body that is to be handed, and then this is identified as a path parameter because we've defined it here with the curly braces. Boom, easy peasy. If you can do path and query and body, that's also easy peasy, as we've already discussed. Query parameters, any parameter that's been highlighted in the path with the curly braces will be interpreted as a path parameter. Any parameter that's been passed a Pydantic model will be interpreted as a body, and any parameter that is not annotated annotated as a Pydantic model and is not defined in the path will be interpreted as a query parameter. The word annotation is really confusing for me, because type annotations is exactly what these are called, and then there's like annotated the function from typing, which allows you to pass metadata. It's so confusing, so irritating for my brain. Function parameters will be recognized as follows. If the parameter also declared in the path, it will be used as a path parameter. If the parameter is a singular type, etc., it will be interpreted as a query parameter. If the parameter is declared to be type of a Pydantic model, it will be interpreted as a request body. And that just gets you most things right out the box. So you can add even further validations for query parameters using the query function, which returns a instance of a class. And the reason it's done that way is because this is meant to be added to the type annotation, as you can see over here with the annotated function from the typing module. I have to clarify, what is this annotated from typing module? I just want to know what type. Is it a function or what is it? I don't know what it is. Whatever. It doesn't matter. So annotated Um, Annotated here is something you're going to need to use, and this is the first introduction to these classes. So for query and annotated, how it's used, so annoying because they're type annotations. You're using annotated, the function inside the type annotation. I don't know if it's literally a function, what it should be called, so I'm just going to call it a function to make my life easier. The annotated function versus type annotations. When I say something is annotated, I'm talking about type annotations. When I say the annotated function, I'm talking about fucking from typing import annotated. So annoying. Okay, with that out of the way. So we have this function called query, which returns an instance of a class with some special attributes that helps FastAPI do further validation, and also it can be used on its own to just declare that something is a specific type of parameter. So for example, if you have a let's go with the body function because there's a similar function to query as body, called body. So if you wanted to declare an arbitrary dict or something like that as a body, it would actually be feasible as long as you use the annotated function in the type annotations and annotate it to be of type body, right? So the first thing in the annotated function is the type, and the second is the metadata. And so basically the metadata of the annotated function in the type annotations needs to use one of these functions to help you do that further validation, right? So in this case, they've used the annotated function. They say string or none, right? So this parameter, query parameter q, can be of type string or none, and you can pass the query function with max length 50, which would also mean that q cannot be more than 50 characters long, basically, right? And also a default value is assigned equals none. So pretty straightforward. See, this is just how you do it. So this is how you do it without annotated, and this is how you do it with annotated. These both being the same thing, but with the annotated typing, you can add metadata, just put a comma and throw down some metadata. So add query to annotated in the Q parameter. This is already done. Data gets validated, by the way, and all that jazz. We've already talked about this. No need to run home the fact that the data is validated again and again. So you can do this without using the annotated function, which would be the only way to do it in older versions of FastAPI. And so you'll see this as code, is where instead of using the annotated function in the type annotation, you actually set a default value. So even if you didn't do a type annotation here, I think this would work even if you just removed this colon string or none. Actually, maybe it won't, I'm not sure. Maybe it will complain because maybe this thing needs type annotations, but basically you set this type annotation and you set default equals none, and you set max length equals 50. This causes issues if you're trying to reuse the function in another place or something like that. So if you're not constrained by technical debt to stick with FastAPI version 0.95 or earlier, I'd recommend not doing this, and that's what they recommend as well. I'm not going to get into it. Add more validations. You can set a minimum length as well, no problem. So there's also, before Pydantic version 2 and FastAPI, the parameter was called regex instead of pattern. Okay, so you can actually also pass regex into the validation. It's called pattern. In older versions of FastAPI, it was called regex. Because it's literally regex. I'm not sure what the renaming thing was. Maybe there's some other pattern recognition thing. You can set any default value, not none. That's just like a regular common sense thing of Python, and FastAPI will also accommodate that, obviously. Required can be none. What does this mean? You can declare a parameter. Yeah, so required can be none. This is something I already pointed out earlier, is if you don't set a default value, and you, for example, set it like string or none, then it becomes a required value, but you still need to actively pass in the value none, because a default value is not assigned. Fine, no problem. Query parameter list with multiple values. You can have like a list of query parameters, which, so when someone is making the call, in the URL would look like this, question mark. So q is the query parameter, q equals foo, ampersand q equals bar, and they can set it multiple times. And in your annotations, you pass it as a list of string, say it's a query parameter, and in Python, inside of that, you will get access to it as a list. No problem. FastAPI will take care of that for you. This is just doing that and setting a default value, which is a list. Also, totally fine, no problem. Obvious things is obvious. You can set that to be an empty list, no problem. Okay, declare more metadata. You can give it a title, you can give it a description. This shows up in the docs, I believe. Let's see. Main.py, command A, command V, UV, no, not UV add rich. I think it's UV fast API dev main.py. I think that's the one. UV run. Yeah, there you go. I'm just gonna click on the docs over here. Did I update? Yeah, I have a title description. Yeah, name. See, read items. No, that's the title is query string. I don't see what query string is. Here it says query string for the items to search in the database that have a good match. That's here in the description. I don't know where the title is used. I have no idea what the title is used, honestly. But point is, like, I'm pretty sure it'll be in the OpenAPI JSON somewhere. Summary, read items, let's just do command F, query, string. Yep, see title. It's there in the OpenAPI schema, so somewhere. Doesn't matter. We're just gonna come back to this. Gonna control C this so that it doesn't use up even more of my battery power. I'm gonna bring this back up here. So yeah, you can just add even more metadata. It's totally fine. Title, description is one of them. We've already covered string validations. We can set up an alias for a query parameter. So if you want the query parameter to be passed as item-query, because that can be commonly used, or for whatever reason you're using a name in the documentation, which you're using a name in the endpoint, which is not a valid Pythonic variable, you can set up item-query. So I'm sure that will show up in the, see? And you can also set it to be deprecated. Deprecated equals true. That's another metadata point you can show up. So in the docs, it'll show up as deprecated and item-query, but inside the Python code, you access it with Q. No problem. You can exclude parameters, exclude a query parameter from the generated OpenAPI schema and thus from the automated document. Okay, so you can set include in schema equals false, then it won't update the openapi.json, which powers the interactive documentation. And the openapi.json is also how maybe someone would programmatically figure this out. and figure out your API. So you can not have it be included in the schema if you want, no problem. That could be some sort of like, so what I'm looking for, like if you're trying to hide an endpoint or a parameter that's to be passed or something like that, I don't know. But for whatever reason, if you want to exclude, oh my god, I'm just gonna lean back a little bit. Oh my god, my back's killing me. Oh my god. Oh, I needed back support. I was like sitting on the edge of my seat for a while. That's acceptable. Custom validation. So there's a class called after validator that's available in Pydantic. And basically, if you have some other function, so this function checks if the ID starts with ISBN or IMDb, you can set in the annotated, set an after validator, check valid ID, right? I actually have a task I wanted to check out wherein can I use after validator with along with some other query metadata. I'm not sure about that. After validator, check valid ID. There's no example for this. Let's just do this live in code. I'm just kind of curious. So Command A, Command V. I'm gonna move myself in the corner while I do this and maximize the screen. I'll open up the docs, the dicky docs. Why won't this open? Oh, because it's already open. Try it out. Execute. Value error, blah blah blah. Which is defined. How is that defined? Yeah, raise value error in valid ID format. Goes through this regular thing, no problem. So 1, 2, 3, 4, 5, 6. So let's set, after this, let's set comma query, which I don't think is imported. So let's import it. Query. Min length equals let's see, what was it again? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's say min length 6. Right, so it has to be IMDb -1. Can't just be IMDb dash. Let's see if that works. Yep. Actual length 5, min length 6. So you can pass additional metadata after the after validator as well. That's a little thing that I actually didn't know about. I wasn't sure. I had like a task in my list that I'm like, oh, no, test that out. But I think those kinds of tasks are pretty much exclusively going to be done on videos like this. So yeah, you can essentially pass in additional metadata with the query function. It totally works fine. Also don't understand why this is causing so many issues. I feel like because I'm using UV to run this, it's not picking up on my environment here, which is fine for now. I don't care. Oh, I'm gonna stop this though too. It's not gonna be a huge drain, but still. Maybe I will just leave it on. Anyways, it doesn't matter. So you can use after validator to write up your custom validations. It'll work, no problem. And I don't understand what this is. Again, iterable object. What is this talking about? Understand that code. So it's passed into the annotated. So you want to add it to the annotated function when you use after validator. I was just explaining this code, which I'm not getting into. It's such a simple piece of code. Um, and then here, if it is none, uh, it'll just get a random item. So list data.items, random item. I don't know what's data.items here. So data.items, random item. And it does a random choice from that, so whatever. That's just like random thing you don't need to know about. Basically, you have the query function, which returns a special instance of a query class. And if you pass this query function with specific parameters like alias, title, description, deprecated, min, length, max, and pattern, these are additional metadata. These will actually help perform validations, and you can use after validator also in the annotated function inside of the type annotations to actually, what's the word I'm looking for? To return the correct type, to return, to do the appropriate validations. Yeah, I think that's everything. So after validator needs to be inside of the annotated function, inside of the type annotations. Jesus Christ, that's such a fucking confusing thing to say. And you can also, something we live tested, you can also use the query function along with the after validator function to do your standard checking, and then on top of that also do the custom validation. Path parameters and numeric validation. So this is where the repetitiveness really starts setting in, and I think it should be a quick shot through the body updates. But essentially everything that we just said, we say it again. For path parameters, we can do validation, pass in metadata. Here it's passed in as title. But I don't understand what's the difference between this one and that one. Oh, it's just running the same code again and again, and it's just showing you step by step, which is silly. So if you're in the older version of FASTAPI, remember that you can't use it inside of the annotated function. You actually have to set it as the default value, set the function itself with the parameters you pass to that function, the path function or query function, as the default value, and you have to set a default value if you intend to set it. Actually, with path, I think you can't set default values. That doesn't make sense. Or maybe you can, I don't know. So order the parameters as you need. Tricks. Here's a small trick that can be handy, but you won't need it often. What is this about? Oh, I remember this. Okay, so essentially here, here it's confusing that the path parameter is defined after the query parameter, and you have to do it that way because you have to define a default value, and Python will complain if you put a value without a positional argument. A value, an item without a default value after a argument with a default value because of some internal Python shenanigans. Essentially, if you define a function and you set a default value, essentially everything gets interpreted as a mix of positional arguments and keyword arguments. So if you have multiple arguments in a row and the last three have default values, you can fill in the first four, right? And then you want to leave the first one and the second one the default value, and just want to use the last one. You can pass it in as a keyword argument, or you can pass in all 6 or 7 or how many ever, I don't remember what this example began, and you just pass them all in as positional arguments. So some weird stuff happening there. That's why you have to rearrange it. And the way to not deal with that, if you don't care, is to just put it after star. You put star and then comma and then everything is always interpreted as a keyword argument. And so then the ordering doesn't matter if you do it after the star, basically. Yeah, that's just some weird shenanigans over there. Better with annotated. So yeah, this is, you just pass it into annotated. Number validators, you can set GE LE, GT, and LT, so greater than or equal to, greater than, less than or equal to. Pretty straightforward. No problemos. You can see here greater than equal to, less than equal to, etc., etc. And you could do that same kind of validation on query parameters as well. If those parameters are some sort of numeric type, you can do it here, no problem. It's as simple as that. Query parameter model. So this is something, now that you're exposed to the idea that functions can be these, I don't know what these functions are called. The query function, I don't know. I'm just gonna call them, because it's getting really confusing to speak about them. Query FASTAPI docs. Let's see. I don't want to go in the tutorial. Let's just say request parameters. I'm just going to call them request parameter functions. So with these request parameter functions in your annotated function inside of your type annotations, you can define basically any parameter to be of any type. And what that means is that I can use a pydantic model and I can use this thing called field within that and assign these default values, and I think this would allow you to also set up a order by literal. I don't know what a literal is. I actually have no idea what this is. I completely missed that before. I think literal is just like an enum. Do they explain that? No, they don't. Jesus Christ. Okay, so I think a literal... What is the literal? I just saw that for the first time here in the typing module. The literal typing allows for the specification of precise fixed values for variables or function arguments. Literal enhances type hinting by enabling more specific type declaration. Literal restricts our function. I'm just gonna go to ChatGPT right now. Literal from the typing module, difference with enum. I'm not gonna dive too deep into this, but I am curious because it seems like an enum essentially. But I guess it's just for, I guess it's not. I guess it's not, because an enum is an actual data holder, whereas in this situation you're saying I'm not like creating it, but this is the only two inputs. So I'll get to that later. I think that's what that is, right? And you can use this thing called field, which I think is something you import. Yeah, you import it from the pydantic, and you use that here to essentially do your validations in the model. And then in the path operation function, you can use annotated function in the typing annotations with this model type as the type, with this model name as the type, and then set it as a query, pass it that query function. So that says to this that everything in here is a query parameter. So when someone reaches to this endpoint, I expect these query parameters, essentially. And if you check the docs, they will show up as query parameters. And there's this neat little thing where you can set model config. And I think there's other things you can do with this model config, but the only thing I have seen so far is you can set extra equals forbid in this dict. And that would stop this function from receiving other arbitrary query parameters other than these ones available over here. That's all there is to this page. I'm just gonna look up the documentation for the field. Documentation Pydantic. Just gonna go straight here. Okay, you can set a default, which is an ellipsis. So you can set a default value here with the, but because it's not part, because you're defining it within a class and not part of a annotated type function, if you wanted to set this and also have a default value, you're going to have to use the default parameter, which I think is set here to 0 and 100, as you can see over here as well in the docs. So yeah, that's everything about this, and that's what we're going to continue on with bodies and multiple parameters. So this is essentially very simple, saying you can mix and match, as we've already discussed, path parameters, body parameters, and query parameters. You can have multiple body parameters, no problem. It'll be read in like this. You can go user item separately. Singular values in the body. So if you want, for example, something that's just an int, importance int body. So if you annotate this as a body, it will be taken as a body parameter, an additional body parameter. I don't know what this is really saying. It's just saying you can have a query parameter along with all this other stuff, no problem. And obviously the body request parameter function also allows you to do metadata and extra validation as with query and path, as we've seen earlier, no problem. Though less relevant because you can do that validation in the Pydantic model itself using the field model from Pydantic. I don't know what the correct words for things are sometimes. Embed a single body parameter. So basically, if instead of seeing if you pass it as single body parameter, and instead of getting this, which would be the normal case, you want it to be embedded like this so that it comes item then the actual body of the Pydantic model, you can pass embed equals true into the body request parameter function in the annotated function of the type annotations. Jesus Christ. And you can embed it like so, no problem. I think that's all there is to say about this. We move on. Talking about fields. Okay, so the thing I looked up, they're just doing in here. You can set up the default title, basically all the juicy metadata and data validation that you wanted to do using the request parameter functions such as query, body, path, whatever. You can do it using this field function, which is a Pydantic function, and set the default values of the attributes of your Pydantic model to this field and give it everything else that it needs, like the default and the metadata and all that jazz. Or you can just set it to not have a default, and that'll be fine as well. That'll be validated, and it won't be interpreted as a default value in this particular instance. Declare model attributes. You can use field with model attributes. We've already discussed that. What's this warning over here? Notice that field is imported directly from Pydantic, not from FASTAPI, as are all the rest. Okay, so yeah, this is important from Pydantic directly. It works the same way. So this is a little info about where the query path and other classes are derived from. They're derived from other basic types in Pydantic. So don't worry about that. You can add other information by looking up these request parameter functions, seeing all the available juiciness to you, and use all of that to your heart's content. Nested models, so you can have a model that is arbitrarily nested, right? So you can have a pydantic model that has a list of another pydantic model, and that's fine, and it'll be represented appropriately in the FASTAPI docs. That's really all there is. It's just like you can nest as much as you want. There's really nothing new on this page. We're just gonna go skipperoonie on this. See, like this is the ultimate example, really. Here you have a pydantic model image. You have pydantic model item that has images, which is a list of image. And then you have the offer, which has a list of items, which has a list of item models. It's totally acceptable, no problem. Can set the default values, all that jazz. Here's a little thing about a different type, which is in pydantic called HTTP URL, which helps validate whether a URL is actually valid. Etc. etc. Notice how offer has a little blah blah blah. Bodies of pure lists. You can have the highest level structure of the body be a list itself, so that's fine. And if you're using a dict, you can obviously do the type annotations, and it will also be interpreted as a body. So totally chill, nothing really much here. So here you can also showcase example data in the model config. Remember how earlier we showed pydantic models, and you can set up the model config with extra forbid. You can also set up JSON schema, etc. extra, and submit examples. One way to do it is this way with model config JSON schema extra, and that is in the pydantic model itself. You can also set the examples using the field function, which is actually which returns a field info instance. No problem. You can set up the examples here. Here's some kookiness regarding examples. If you want it on the body, in the entire body, you can pass it here, though honestly I think in both of these cases it will be rendered in the same way. In fact, let's just test that out. I'm pretty sure it'll be rendered the same way because it updates the OpenAPI schema the same way. I'm just gonna click on this over here, command click. Let's open up the docs. This is the example values that are defined in the pydantic model right here. And if we do the other one where it's declared in the body request parameter function inside of the annotated function, you can take that, boom. Oh, nope, cancel. A, B, that should restart the server. It does. And I'm just going to refresh this page, and it's exactly the same. So there's no real problem there. You can do it either way. I think there's some edge cases where it would be valuable to know that you can do it in multiple ways. You can also pass multiple examples here, as well as in the specific examples in the field type as well. The examples will be part of the internal JSON schema for that body data. Nevertheless, at the time of writing the Swagger UI, the tool in charge, I'm just going to pause this for a second. All right, I'm back. Sorry, there's some stuff going on. I was trying to figure out what was going on. Basically, this is multiple examples is supported, but it won't show up in the Swagger docs. There's some weird jazz regarding it, and basically, if you want it to show up in the JSON docs, you have to use OpenAPI underscore examples in the body parameter, or I think it maybe is available in the regular field. I don't think so, because field derives from pydantic specifically, and OpenAPI examples I think is specific to FastAPI because there's some weird historical stuff where the standard for JSON schemas versus the standard for OpenAPI schemas was conflicted on examples because OpenAPI had one, JSON didn't, and then JSON at a certain point did, and then OpenAPI switched to using that one. So this is a whole weirdness there. And so if you want multiple examples in your Swagger, you're going to want to use OpenAPI examples, basically. It's as simple as that. So there's also added example and example fields to other parts of the specification, like query path, header cookie, body file form, and JSON schemas examples fields with the JSON. Okay, whatever. I'm not going to get into this. There's some history and some weird stuff that will explain the difference. But the key is, if you want to see multiple examples in the interactive documentation, when the body function or with the other request parameter functions, you're going to want to pass OpenAPI underscore examples. We're going to move on because at this point I'm starting to run out of juice. I've full charged my laptop with my, well, not full charge, I brought it back to 75% with my power bank, and I'm putting my power bank back to charge. So, but I highly doubt I'm gonna be able to eke out this level of battery for this long. So I'm gonna rush. I know I could just like stop the recording and splice together a couple of videos, but I'm gonna want to take this. Boy, to extra data types. You can use more complex data types that you can get from different places. So there's UUIDs, which you can get daytime, 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 date, daytime, time, daytime, time delta, frozen set, bytes, decimal. There's like a bunch of different things, and you can use them all in FastAPI, and it's all, you can annotate it as such, and it's totally fine, no problem, from UUID, import UUID, all of these different Pythonic types that are mostly all supported, I'm guessing. That's about all there is, and you can, if you annotate them as such, whatever the JSON received will be interpreted or coerced into this data type, and then you can use it completely Pythonically inside the actual function, no problem. Go to cookie parameters. Cookie parameters is essentially cookies. Small aside on what cookies do, it's essentially cookie, because that's what I thought this page would explain, but it never did. And cookies essentially live on your browser, and they help. Basically, there's a piece of info that is given to that cookie, which is then returned with each object. So like a session ID is an example, or that this person has been logged in for so long. And cookies also expire. Basically, any parameter annotated as a cookie using the cookie request parameter function will be interpreted as a cookie. That's all there is to this. Same thing with headers. Literally the same thing with headers. There's really nothing new to be described here. Okay, yeah, so headers automatically convert, because the standard is that header parameters are like, if it's a multiple word thing, so it can be X token, so it'll be X hyphen and then capitalized token, so you can set the convert underscores equals false if you don't want that to be the case. And so X, but if you don't, it'll be X underscore token will be converted to X hyphen token. And if you don't want that, you can switch that. If you for some reason need to disable automatic conversion of underscore hyphen, set the parameter to false. So then, like, someone who wanted to pass an X underscore token would literally have to pass X underscore token in the header parameter, which is just socially, like, speaking in terms of the social norms of how APIs and header parameters, all these things have been socially defined. There's nothing inherently stopping you from doing these things, but they're just generally accepted, right? And you gotta be careful about that, because people can take advantage of it, but it's also important to maintain that because it makes a dev team easier to function, right? So anyways, cookie parameter models. So same thing as we discussed about query parameter models. You can bunch a bunch of things together into a pydantic model, and you can pass that pydantic model into the type annotation of the path operation function using the annotated function and annotated as a cookie. Then that pydantic model, like all of the attributes of that, will be interpreted as different cookie parameters. So it's pretty much simple, and you can do for a bit extra cookies with the model config extra 4-bit, and that's about it. Like, it's pretty much the exact same thing with headers. You can do the exact same thing with headers. That's really what it's going to say, nothing special. And in the header itself, since you're you can set the convert underscores to false as well. Totally fine, no problem. That's the same as in the header parameters, if I remember correctly. Right? Yeah. Basically, it applies even if you use a model. So that's a small thing. Response models, return types. So this is the annotation for what the function actually returns. They didn't actually talk about that this entire time. And this is how you define what you're going to return and get the things for that. So you can do a pydantic model, a list of pydantic models, right? Usually your response object is some sort of body. You can validate with these annotations, you can validate the return data and add it to the JSON schema to be used by interactive documentation. Also helps with edit support, and this is the most important part, will limit and filter the output data to what is defined in the return type. Why is this valuable? So there's something, so going into the example we're about to talk about is important. Jesus Christ, this is really long. I don't know how long I've been recording for. I'm trying to find out. It's been a while, but soon the battery's gonna give through. So essentially, if you, instead of returning, setting the type annotation to the type of the model, you can set it to type any, and you can, in the decorator function that defines the path operation, you can pass in response model and give it this type. It kind of messes up editor support, but other than the editor support, the type validation, everything still works. Why would you want to do that though? That's the question, right? So imagine basically you have a class like this, you have username and password in there, and you need to do some manipulation with this user ID and return it back, right? Let's say you want to update someone's email, and then you want to send a return updated to this, let's say, right? It would be just overhead to create a new model for that. You essentially wanted to go back without this field. You don't want password to go back out because that's really bad. And honestly, password should never be saved as plain text. So never do that. These are all examples, right? There's also, I don't know why they bring up about email validator here, because they use that type here, email string, so it doesn't matter. Where it becomes helpful is over here, where you can set response model equals user out, right? And then just return the model that you got, right? And as we said, by doing this, or even setting it in the type annotation, either way, it will filter. And the reason we do this instead of this is so that the code editor doesn't complain. And there's a way around that, but we'll get to that in a moment. Is that essentially this will then be validated by the schema of user out. And so the password will be removed from this object before it gets sent in the response object, right? Because it gets coerced to this data type. So that's where this becomes really valuable, especially when you're playing around with similar objects, except one has some sensitive data, and you essentially just want to manipulate it and send it back. Just makes the code a bit neater and stuff like that. This is essentially just going through that. So another way to do that would also be to just use inheritance and be like base user is what gets returned, even though we're returning user in. So this makes it so that you don't have to use the response model parameter in the path operation decorator. And instead you just do this, and this is accepted because even though the return type is of user in, since user in inherits from the type base user, your editor won't complain, and you'll still get all the validation and the filtering and all that. So what gets returned won't have the password, right? And you can take this further. Okay, this is a completely different topic. I don't understand why we go into this topic here. Very weird place for it to be in the documentations. But essentially, you can use the JSON response object or the redirect response object and return that directly. which I think you might want to do in certain cases. Or something that is not a valid pydantic field and you annotate it in the function only to get the support provided by tooling. Would be returning response directly as explained later in the advanced docs. So for some, we'll get to it in the advanced docs that there's a reason to, but you can do that, no problem. And you can annotate it as such, no problem. And if you just use the generic response class, it'll accept redirect response and JSON response and other response type objects that inherit from this. Or, you can also be more specific, whatever, doesn't matter. Invalid return type annotations. So yeah, this apparently will cause a problem if you do response or dict. The same would happen if you had something like a union between different types where one or more of them are not valid. For example, this would fail, but when you return, okay, wait. I forget, there was a reason why you couldn't do this. But when you return some other prime arbitrary object that is not a pydantic type, example, a database object, and you annotate it like that in the function, FASTAPI will try to create a pydantic response model from that type annotation and will fill. Let me double check my recording because I'm super scared. Oh, okay. So FASTAPI essentially, when you do something like this, some sort of like multiple grouping of this, in the background, FASTAPI will try to create a pydantic response model from that type annotation and it will fail. And that's why this is not acceptable and you can't really do that. Continuing from the example above, but you might want to still keep the return type annotation function to get support from tools like editors. In this case, you can disable this response model equals none. That'll make FASTAPI skip the response model generation, and that way you can have any return type annotations without it affecting your FASTAPI applications. So basically, if you do want to do this, you gotta set response model equals none to stop to stop FASTAPI from trying to create a pydantic model, which is what will cause the error. Encoding parameters. I don't know what that means. I don't know why they say it like that, but essentially this section is about the parameters in a response model and the ones that set default values. So you can set it so that response model item, response model exclude unset equals true. What this means is that this function, even though in the pydantic model you have defined default values, tags, and description, if you set exclude unset true, all the data received on this endpoint, when responding to it, when sending the response, anything in the response model that wasn't set up, was just aka an affect of the default value, it will be not returned. So basically, if you set this to true and you try to get the item foo, you'll just get foo and this. That's it. But if it's already filled up, it'll show up, and even if it's filled up with default values, it knows that even though it's the default values, it was set manually, therefore it'll be returned. So you can have response model include and exclude, which basically means only return with this or only return with that. sorry, don't return with this. So in this first one, item ID name, you just return the value and you ignore the name in the description. Sorry, you only include the name in the description. And here you wanted to exclude the tags. So item ID public. If someone hits this endpoint, they'll include the tags. Using lists instead of sets, so you can set a list of items. So yeah, okay, that's a thing. These things take sets because they're supposed to be unique. The response model include and exclude. You know, this thing is bothering me. This exclude unset equals true. Never mind, I'm not gonna get into it right now. I'm not even sure if I'm defining the question smartly. So response model equals exclude equals tags means that when you respond with this, the response model item will be used and we won't return tags. It's pretty straightforward. And if you give these parameters something other than a set, you give it a list or a tuple or something like that, it will be interpreted into a set, no problem. And that's everything on this page. Extra models. So this just continues on with the issue of return types as described in the earlier example on the previous page. This is very weirdly split up. I don't know why it's done like that. It's just some random info, first some important stuff regarding how the response model stuff works, but then it just kind of dives off another end to talk more about parameters to the path operation decorators. So anyways, here is essentially a method for avoiding the issue with returning the same type with sensitive data. So you can use class inheritance and just have separate models with the different passwords, and as long as you have the type annotations or use response model, it'll do it correctly. So here it's just explaining * user indict. So this is basically user indict dot dict. The dot dict is, it's actually deprecated. It's a Pydantic function of a Pydantic model, and it just dumps the model to a dictionary. And it's been replaced by model dump. So wherever you see dot dict, you were actually talking about model dump, which has a few more, some other stuff, but dot dict is still supported. And I think it's just a quiet redirect to the other one or something like that. And * just unpacks it. So when you dump it to a dict, the * unpacks that dictionary into a set of keyword arguments that you pass into a function. And in this case, in a function or class or whatever, in this case, it's taking user in, takes the dot dict and passes it into user in DB and creates the user in DB object with the new hash password. That's just like a little neat thing about how to manipulate Pydantic models, and that's just what this is explaining. You can reduce duplication further by just having all of these inherit from user base, which is separate, and then do it that way. Union, plain item or car item. Yeah, so in the response model, you have to use the word union if you're not using the type annotation to say union, plain item or car item. If we're talking about different item types. In the response model, in this example, it passes the value of the argument because we're passing it as a value to an argument. Instead of putting it in the type annotation, we have to use union. Even in Python 3.10, this is what I just said. The response model can be a list of items, no problem. Response model can be an arbitrary dict, no problem. Response status codes. So all of these path operation decorators, they have a parameter called status code where you can give it an integer and that'll give you the status code. Your general status code ranges are 0 to 100, 100, sorry, no, not 0 to 100. let me see. Yeah, 100 to 199, 200 to 299, 300 to 399, 400 to 499, and 500 to 599. So these are all different ranges, different numbers that represent different things. 100 to 109 are informational. You will not do them directly. Something done by the server or other things, I'm guessing. 200 to 299 is for successful responses. 300 to 399 are redirections. 400 is a client error, like so someone who made you a request, someone who makes a request to you has made an error in that request, wrong type of data or whatever. And then 500 to 599 are server errors. So somehow your server crashed, something happened, that's your fault, and that's a different type of status code. Shortcut to remember the names. So you can also use enums, typing enums. FastAPI has its own status, so you can use status.http 201 created. That's pretty much all there is on this page. Form data. So in the good old days before JSON, data over networks were passed as form data, which is from HTML tags. There's a form tags, pairing of form tags that need to be used. Let me just pause the recording. Alright guys, so I actually got pulled into some stuff today. So kind of headed off around 2 hours ago. There's a lot of stuff I want to hide. Let me close that actually. We'll leave the code up. So we're just continuing where we're at. So form data. Form data is pretty straightforward. Before JSON, one of the ways HTML used to send data was wrapped in form tags. So it's called form data, and it had its own structure and style and whatever. And similar to the other request parameter functions, there's also a form request parameter function right here, which you can annotate, and you can annotate I'm just going to say annotate from now on. Instead of saying the whole thing, understand what it means. Annotate the type hint that it is of type form. And so then it'll be parsed as a form data type. And it'll understand that this is happening. One thing to be noted, that the media type is, when you're getting form data, is application X www form URL encoded. And also with files, you get multi-part form data. But because this is the media type, it is incompatible with application JSON. So you can't have body parameters along with form parameters. Moving on to the next one, form models. That's exactly the same as we talked with query models and header models and cookie models. If you want, you can, as long as you annotate the class, the pydantic model that is created as type form, it will be read as the attributes being of form type. Simple, straightforward, and also you can define the model config extra forbid, and also you can probably set examples for this as well. I'm not 100% sure. That would go into JSON schema extra. That would require experimentation, but I'm really close to the end, and I'm also kind of hungry, so I want to finish it, eat, and then I'll finish reading for today, because this video ended up being insanely long. So I'm probably, my initial thought was tomorrow I'll go through the entire doc for the entire user guide. But what I'm thinking is I'll go back to my regular schedule of like doing the updates, and I'll just try to make the updates as big and meaty as possible, and then have one video for fucking everything. And I'll probably have like some prelim videos leading up to that video, trying to describe and connect all of the concepts in like a free form PDF, so that I can just explain the entire docs that way. So here is, that's just a random aside about how I'm going to do that. So you can create form models, and you can forbid the submission of extra form data. It's about that simple. Request files. You annotate it as type byte. You use the file request parameter. Pretty straightforward. There's also upload file, for which you don't need to annotate because it's both. It is a type and it's in and of itself. And essentially, the difference between this and annotating bytes with file is that with upload file, you actually get a Python object exposed that's known as a spooled temporary file, which means that if the file is running over the disk, if the file is running over the disk, then over the memory allocated, then it writes to disk. So that's what a spooled temp file object is, and it exposes a few async functions that you can run on read, write, a couple others I can't remember. They'll probably say it down here somewhere. And it's a Pythonic file-like object, so you can just hand it off to something else instead of like converting the bytes to a file object. Yeah, there you go. Write, read, seek, and close. And yeah, that's pretty, and they're all awaitable async functions. Be careful of that. If you're inside a normal def path, or you can access the upload.file directly, for example. For us, all this. Okay, so if you do this inside of a regular function, you can just do the regular one. Otherwise, you have to await it. Using upload file has several advantages over bytes. You don't have to use file, and the default value of the parameter uses a spooled file stored in memory up to maximum. This means that it'll work well with large files. You can get metadata from the uploaded file. And it has a file-like async interface. I don't understand. You can get metadata from the uploaded file. I guess the content type, the file name, I guess that's the metadata it's referring to. You can set that as optional. I think this is what they mean, where basically you can annotate with the type upload file and then give it the file request parameter function and add additional metadata. But I feel like you can do that. Yeah, see, in the previous one you can do that. It just says annotate bytes file. So I don't understand what it means by upload file gives you additional metadata. I think it just means maybe the file name, the content type, the file. I think it just means this basic attributes. I'd have to check the upload file object inside of an IDE or something like that, or just check the SDK reference, I guess. Upload file with additional metadata. Okay, we talked about the multiple file uploads. You can do that. You can just do list of upload files. Or I guess you could have multiple just separate file types uploaded in as separate parameters. I think that would work as well. I don't know. Multiple file uploads with additional metadata. List of upload file, file description. List upload file just allows you to add as many files as needed, I think. Return file names, file name for file and files. Recap. Yep. This is pretty straightforward. There's really not much to say other than there's a file object and there's an upload file object, and they basically work as all the other request parameter function types, except for upload file, exposing the spooled temporary file object. So request forms and files. What is this about? This is essentially saying that file is a derivative type, and along with file you can do form types, which was described earlier with the fact that it contain multiple file and form type, but you can't also declare a body because file types are considered form data, and so it would be incompatible, because then the media type would be application whatever or multi-part form data. Application, what was it? URL encoded something versus application JSON, and it's just part of the HTTP protocol. So you can do form parameters beside it, but not much else. So yeah, handling it. I guess header parameters and cookie parameters still work. I'm not sure about that. Handling errors. So this one's important actually. So when you want to when there's an issue, usually when there's a client side error, means they sent you some wrong data or something was messed up. You want to raise an exception, like your 404 not found is a common one, right? The way we do that in FastAPI is we import this HTTP exception, and we raise it within the function like we raise a regular exception, and that would return. It would send a response object um, with the status code and all the details, right? So this is more Pythonic rather than actually just returning a separate object that is a Pydantic model of HTTP exception type. Instead, you just raise an exception, and I'm assuming it's part of what the decorator function does. It just handles it and returns as a response the 404 and everything, and we continue with normal execution. So you can give the status code, give it some detail, and I'm sure there's other things you can add to it. Oh yeah, you can add custom headers for the HTTP exception. Once again, you can check the SDK, and I will too at some point whenever I'm using it, to double down on understanding that. You can have a custom exception handler. So there is a exception handler function from the app object, which is a instance of the FastAPI client, or I'm just going to call it from the FastAPI client. That's what I'm going to call it from now on. That makes a lot more sense. So from the FastAPI client, you get the exception handler function, which you have to give it an exception type, and then it's an async def function that will get the request object and the exception, which is of type unicorn exception, and then you return whatever response, like in this case a JSON response, which you can get from FastAPI responses. I believe this, and they've mentioned this in other places, where a lot of these things are, you can get it straight from Starlet as well, because FastAPI is also built on top of Starlet. Starlet is a lightweight ASCII framework toolkit. There you go. So yeah, ASCII stands for, what does ASCII stand for? What does ASCII stand for? Asynchronous server gateway interface. There you go. Because I heard ASCII a lot. I never knew what the asynchronous server gateway interface. There you go. So now from here on out, if within your app something happens and you have to raise an exception of this type, and then that gets handled by this, and this returns your status code and everything like that as a traditional JSON response object with everything that it needs. So that's how you do custom exceptions, exception handlers. You can override default exception handlers, so you can essentially call at exception handler and just pass it the what's the word I'm looking for? The error that is normally handled on its own. In this case, a request validation error. And then you can just pass that to the exception handler, so it knows to use this function whenever this exception is raised, and that would just override the default exception handler for request validation error. And it's interesting, I think it might be in the next couple of pages, but you can also, or maybe it's on this page itself, you can also override, and not just override, but reuse the original exception handler. So if you want to create an exception handler where it's essentially the same as the previous one, except you want to add a little something, some little Genevieve to it, you can do that, and that's not a problem. And then similarly, if you want to overwrite the HTTP exception, it's a little weird, because to differentiate from raising an HTTP exception versus actually doing the exception handling, Essentially, the HTTP exception that you import from FastAPI is the exact same as the one from Starlet exceptions. Um, and so you rename it as Starlet HTTP exception. And for some reason, you have to do that if you're trying to cat an HTTP exception. You want to do some custom handling for an HTTP exception instead of the traditional one. Request validation. So request validation error is a subtype of pydantic type called validation error, and FastAPI essentially built it on top of this because they wanted the error to be shown in your logs, but they wanted it to not go back to the client. The client would see status code 500. If you have a pydantic validation error in your response or anywhere in your code, none. And they do that because, if the bug is in your code, in your response or anywhere in your code, not in the client's request, it's actually a bug in your code. Okay, I get it. So essentially, what they are saying with this is actually interesting. I don't know how I missed that. I must have been tired when I read it, which probably was. But essentially, what this piece of code is saying is that the request validation is something that they wanted to handle separately from just a generic validation error raised by Pydantic, so that when they see a request validation error raised, they know that they can return it to the client with confidence because they screwed up. But if a generic validation error is raised, that should be sent to the client as a 500 error because a regular validation error could signify an issue with the response objects you're using or the other Pydantic models you are using, right? So while you fix that, that should not be exposed to the public. Whereas requests, aka the incoming data, if that has an issue, that should be responded to. And that's why we have a separate request validation error versus the Pydantic validation error. I don't know how I missed this. That's a little interesting tidbit. See, even here it says response. Okay, plain text response is just from, is a different thing. I think on another page or maybe later on this page they explain. Yeah, there you go. Fast API's HTTP exception versus Starlet's HTTP exception. Let's read this as well because this is what I was trying to explain earlier. Oh man, I'm sneezing. Was what I was trying to explain earlier, and I don't think I was doing a good job because I don't think I understood it very well. Fast API has its own issue. Okay. So essentially, the reason they use Starlet's HTTP exception, I mean, you have to import it separately because it's the same name as FastAPI's HTTP exception. But FastAPI's HTTP exception is built on top of Starlet's, except that FastAPI's accepts any JSONable data for the detail field. But when you want to catch it, you're going to want to use the Starlet HTTP exception so that it's just broader. It catches anything that Starlet itself might be getting wrong or something from a Starlet extension or maybe somewhere else in your code. You're just using Starlet HTTP, Starlet directly, and there's some issues there, right? So to be able to catch both the Fast API HTTP exception and Starlet HTTP exception, you just get that, and to have both of them in the same code is why we do it this way. So this is the fun stuff where you can actually reutilize the same exception handlers. So you can import the exception handler separately. See, if you want to use the exception along with the same default exception handlers, you can import and reuse the exception handler. So at app exception handler Starlet HTTP exception, you can have this be printed, and then we move straight to the await on the actual exception handler. So that's interesting, neat. Path operation configurations. What is this about? So this is essentially, this page is mostly talking about what you can do with the with the app functions. So with the client, with the Fast API client functions that define the path operations. So that's mostly what this is about. We know about response model, so that way you get the type validations for the response model. The other way to do it is just to annotate it on the function itself directly. You can set the status code, and you can use Fast API's own status enums. There's also one provided by Python directly as well. I forget what it is called. I think it's just HTTP status, something like that. I'm gonna move the camera up here because I forgot I did that. You can use Starlet from Starlet import status. Okay, never mind. This is just saying that you can get status from Starlet directly. It's just given as a convenience through Fast API as well. You can add tags. So tags are, I don't know what tags actually do. Oh yeah, I think it's essentially added to the OpenAPI schema and allows it to like differentiate it a little bit over here in interactive documentation. Tags with enums, so that's, I feel, pretty straightforward. You can set up tags and you can pass it enum objects, totally fine, no problem. I don't understand why the tag is given as a list. Remember, tags with a list of string, commonly just one string. So I don't understand okay, if you have a big application, you might end up accumulating several tags. There you go. That's why. Oh no, this is the enum class thing. So yeah, this is why you want to use enums. Basically, if you're using multiple tags and you're just writing, uh, adding tags to like multiple path operation functions, and you have like a huge number of them, it's an easy way to make mistakes. So that's why I use enums. Um, you can add a summary and a description that'll show up in the docs. The description is also inferred from the doc string, and furthermore, if you add, what's the word I'm looking for, add markdown to the doc string, it will be interpreted by the doc string. So as you can see in this image over here, you can have a separate response description for the response item. Notice that response description refers specifically to the response. The description refers to the path operation in general. Okay, yeah, so the description thing or the description from the doc string refers to the path operation function in general, and the response description is specifically for the response object. Declare a path. Oh, deprecate a path operation. This was showcased earlier. You can set it to deprecated equals true, and boom. That's basically all this page is. JSON compatible encoders. So they have a function called JSONable encoder, and when you need to, it helps you encode data as a JSON. That's about it. It's pretty simple, helpful if you're going to make other calls within your model. Example, connecting to a DB or writing to a DB or whatever. That's really all it is. Pretty straightforward. Result of calling. Okay, in this example, it will convert the pydantic model to a dict and the datetime to a string. Okay. Yeah, so the result of calling it is something that can be encoded with the Python standard JSON.dumps. So essentially, there's the reason they use JSONable encoder instead of just like using the model dump or .dict, because that, when you do the model dump, it dumps it to a Pythonic object, which can have types like datetime or other complex types that need to be converted to string or some other more malleable type that can then be used by JSON dumps to actually convert it to a JSON. So that's what JSONable encoder does. It doesn't return a large string containing the data in JSON format. It returns a Python standard data structure with values and subvalues that are all compatible with JSON. There you go. JSONable encoder is actually used by FASTAPI internally to convert data, but it is useful in many other scenarios. Yeah. Body updates. And I think this is the last one, and the video finally ends, because this is where I got up to, and everything else I'm going to read by myself. Update replacing with put. So this is kind of interesting. This is talking about updates and some weird funkable stuff, which is where JSONable encoders and other stuff comes into play. So put is essentially an update. If you have something, it updates in place. Now put updates the whole package. So basically here, the new item is encoded to the JSONable item. You add that to your, in this line, your database. It's not really a database, it's just a dict of dicts, but in a real API operation, you want to write this to the database, and this is kind of like the drop-in for that. Update item encoded and return the updated item, right? It's simple as that. Now here's a warning, and this is a fair point, is essentially using put with a body containing this. Basically what the warning is saying is that when you're essentially creating a new object, and when you do that, if you want to update the item bar using put with a body containing this, because it doesn't include the already stored attribute tags, the input model would take the default. So this isn't actually about the code per se, because I think this code is not relevant to this. I'll tell you why. Because in this situation, whatever is given to us is turned into a JSONable encoder. But then again, if someone gives us something and this is type validated, so it is relevant here. It is relevant here. Yeah. Okay. Okay. Wait, let me back up and say this again. So essentially over here, because of the type validation by Pydantic and the fact that we've annotated as an item, we get a brand new item object handed to us, right? And when a brand new item object is handed to us, this object has a few default values. So if you are given, if the user, the client, sends you something and it will create a new Pydantic model, there could be confusion because when you just update that value with that model that you've received, it will update it with the default values because it's essentially a brand new object, right? So if you do a full replacement and the user actually just sends 3, it's still going to have the tax attribute because tax has a default value, right? And that's an important thing because well, it's not an important thing, but it's just important to know, right? And there's a few ways you can get around it. So first of all, I think for put, that's fine behavior if you document it in your API that this is what you'll get. Because put is meant to be like an idempotent, as long as the user doesn't change anything, an idempotent update, like it'll always result in the same object. Right? So you just replace the whole thing. Whereas with partial updates and patch, which is a different verb and it's not used that much, and that's a bit different where you can do partial updates. So there's exclude unset in Pydantic's model dump, which essentially excludes the unset default values, and I think we showcased this earlier in some other situation. I completely forget in what situation. And so you can use model dump and exclude unset equals true. And so when the model is dumped to a dict object from a Pydantic model, it won't have those default values, right? So if you're doing a partial update where you need to be really sensitive about what the user sends you and only update that, you're going to want to use that as they show here. Now, this code initially took me a moment to understand fully, so I'm just going to go through it now, even though they actually describe it a little bit better later on. I'm just going to walk through this anyways, instead of going through this. Essentially what's happening here is in this situation, and this is essentially trying to showcase how to use exclude unset equals true for something like a patch operation where you're requiring a partial update. You set so stored item data, so from the item ID given to you, you're supposed to update it with this item. So given the item ID, you retrieve what was already stored in your database, right? Or this dict of dicts, but the database, we're going to call it that. Then you create a new model from the stored item database because the database isn't necessarily going to return it in a manner that is like a Pydantic model. And so it's nice to have it that way to make sure data validation and everything is happening on its own when you try to well, in a moment you'll see when you try to update the data. So to update the data, you call the .dict or .model dump in Pydantic v2 onwards. Exclude unset equals true. You do that, and so then it dumps the model that you received here, item, to a dict without setting the default values because it's not because this is a patch. And then you copy that into the model using the parameter update data. So copy is also a deprecated function like .dict. Now it's .model underscore copy. And you pass it the update. So that in that situation, essentially you take a shallow copy of the Pydantic model and you just update this data into this copy. That's it. And then you encode it once again to send it off to where it needs to be. So if you do it this way, this gives you like Pydantic, like type validation and all that jazz while you're doing it. So that's important. I don't think I explained that very well, but I think I understand it. So that's what they're going through over here. Partial updates recap. Put that data with generating a dict without default values. So this way you can update all of the values, create a copy of the stored model, and update new subject using the update parameter. I feel like this kind of misses the point of why would you do all this of converting to Pydantic models and things like that. And it's mostly for the validation. And because it wouldn't, since we're using .copy and setting update data, and this is a not .copy as in the function of the dict type, but like a function of the Pydantic model type, right? So it operates a bit differently. That's why it was deprecated, and we switched to model underscore copy and model dump. Honestly, there's really not much else to say here. I'm just going to read this in case I missed something. Create a copy. Okay. You can actually use the same technique. I don't think the copy technique actually does any data validation. Now I'm thinking about. Let me look this up because I actually do remember looking this up. Command up model underscore copy. I'm going to click on this. Update. Values to change / add, and note the data is not validated before creating the new model. You should trust this data. Yes, it's not validated. Set to true to make a deep copy of the model. Okay. Then why would I do this? Why would I do this like this? So if I read from, outside of the arbitrariness of this example, which kind of necessitates it, why would I use this like this? I'm trying to think about that. So I take the data from the database and create a new item model, and I dump the data from the request object to a dict, and then I copy that into the model using update equals update data, even though update equals update data does not actually okay, so there's some validation in the sense that, but the validation isn't in the copy. The validation isn't in the copy. Then what is it? If the validation isn't in the copy, well, it's in the fact that item itself is a Pydantic model, so it has to be validated before it gets to you. So when you do this, you're guaranteed to get the right type of data. So then why not just do this? Because if you're doing a partial update, you don't know if what was excluded. If you're doing a partial update, you don't know if what was excluded is previously set or not set, right? So anything that is unset from the incoming model should be dropped, but whatever was there in the original needs to stay. Okay. But then again, if you did this and it was not there in the original, then because you created an item type using that, that's just going to create the default values. So once again, why do it this way? I think this is just to showcase that you can, and there must be something that makes sense, but this does not make sense. It does not make sense. I don't understand why they actually wrote this out. It's the weirdness. Okay. So the input model is still validated and all that jazz. So if someone wants to do a partial update, that's basically what this note is saying, is that what am I trying to say? Man, I'm hungry now. I'm just thinking about food. Let me just finish what I'm saying. Basically, if you want to create a path operation where you can literally update anything, you could use the thing they say in the extra models thing where they had inheritance and all that stuff. So you could essentially create a model that is the regular model, the one that's supposed to get validated, and you could create another model that inherits from that model, or you could just create another model where all of the options are optional, right? So that would really help with that. So, yeah. Okay, so that was a bit of a bummer note to end this on. It's not really a bummer note, but yeah, this has been a marathon. I think this is a 3+ hour long video, because I know the first video was 2.5 hours long, and I think this is about an hour or so what I did just now. Okay. Yeah, this was me biting off a bit more than I could chew. I guess I really wanted to make up for yesterday. I hope you guys have a great one. I hope this helps someone. All right, take care. Bye-bye.